Hi, I'm going to talk to you today a little bit about the science of tree rings and discuss partly of the collection of tree rings first. So one of the aspects of my research that I do is collecting remnant wood. Remnant wood is pieces of wood that from a dead tree that still have the presence of tree rings, and so I can take a look at those. But safety, of course, is very, very important anytime I'm using a chainsaw. So I have chaps for the protection of my legs, gloves for my hands, and of course I'm also going to have a helmet. So for the collection of the remnant wood, I'm going to be using a chainsaw, and you'll notice the face guard that I have will protect my face from any pieces of wood that might be flying out while I am chainsawing it. Now you'll note that that stump is rather big and still large, and I don't want to take that whole piece of wood back to the lab with me. So what I'm going to do is cut out a cross section of that piece of wood, and I'm going to start by taking off the top of that stump. And what I ultimately want to do is I want to try to only bring back a small piece of that stump, because you may be several miles from your vehicle and you don't want to have to carry a big piece of wood back to that vehicle. So we try to take back a small piece such that it's easy to carry, and we can carry several of these at the same time. And probably the best thing to do here is just kick that stump right off of there. So I cut the top off of it, I take a quick glance at it, and now I'm going to cut a small section of this out. In a lot of cases, I want to let the chainsaw do the work. I don't want to force it through the piece of wood, and just let it cut. And you can see I'm just taking a small section of that stump, but on that is going to be a series of tree rings that I hope I will be able to tell how old that tree was before it died and how many tree rings it had. Now I'm finishing up, just about finished cutting that section out. So I have that section, and usually what I will do is take additional information about that piece of wood, like where it was on the landscape, by using GPS, so that I can look at those characteristics. Now what you'll notice with this piece is that it's a nice section of wood, but in many cases really difficult to see individual tree rings at this point. I can get an estimate, but certainly it's still kind of rough. The cut of that was rough, so I want to bring that back to the lab. Now what you'll notice is that where the arrow is pointing, that's the pith, that's the center of the tree, so the outside is closer to the bark there, and so the rings are going to be structured like that in what you see. The second aspect of this is collecting pieces of wood from living trees, and we do this by using increment coring. And there's the tree that I'm going to be working on. That little instrument that's orange in my hand, that looks like a tube, is actually an instrument we use to bore into the tree to collect a small piece of wood, which is a little bit different than what you saw with the previous segment of the video, in which I was collecting a whole section of it. dead tree. Well, this living tree, I don't want to necessarily cut it down to collect the tree rings. So what I can do is actually bore into the tree and just take a small piece of the tree out. That way the tree can recover from that injury and still grow, and I will have a small section of wood that will have tree rings on it. You'll notice that it twists. What I'm twisting as it's going into the tree, and what I'm trying to do is estimate where I think the pith or the center of that tree is located. I don't want to go all the way through the tree, and you'll see I'm using that piece of the increment board to estimate how close I think I am to the center of the tree. So I'm going to take 5 more turns just to make sure that I'm close. And that instrument that I'm inserting there is the extractor. And so I can insert that, and then with one twist in the opposite direction, I can pull that out, and on that extractor will be that small piece of wood that you'll see here in a minute. So in many cases, to do tree ring science, we don't need a large piece of wood in order to look at how old the tree is or how the tree was growing. And what you'll notice here is that on the inside, the pith, where the arrow is pointing, that's the inside of the tree, and the bark on the outside of the tree. So now the second phase of our sample is to bring it back to the lab and prepare it so that we can look at the tree rings. We go through various stages of preparing the sample that we had cut out in the forest. The first phase is to use a portable planer, which is the instrument that I am holding in my hand there, in order to carefully cut away some of the rough parts of the sample. In the background there, that black rectangle is taking away some of the sawdust that, as you can see, is shooting out the side of the planer. And what I'm trying to do is just smooth out some of the rough spots. And this is going to be really the first phase of any sample that we bring back that is this large. For the increment cores that we take out of the tree, we don't necessarily use this instrument. It's really designed for just working on large samples like this, so that we can see individual tree rings later on. I'm moving it around in a circle in order to just touch up some of those rough spots that you can actually see on the piece of wood there. The next phase is to use a series of sanding instruments. The belt sander that you see pictured there, with the arrow pointing to it, and then I'll finish up with an orbital sander, which will put a finer finish on the piece of wood. So that piece of wood that I was just using the planer on, I'm now going to use a belt sander, which will finish up taking off any of the rough spots on that piece of wood, so it's a little bit easier to see the tree rings. So each of these different instruments, the planer, the belt sander that's in my hand there, and then finally the orbital sander, will all put a much finer finish on that piece of wood. Finally, I'm going to take the orbital sander there, and we're going to be using a series of different pieces of sandpaper that are, some of them are very rough, and then we'll work our way towards pieces of sandpaper that are much more smooth, and each piece that I use will put a finish on that piece of wood that's going to again make it easier to see the tree rings. And so the piece that I have right there is what we call 80 grit sandpaper. And it's the roughest sandpaper that we have, and what this does is it's going to polish up some of the spots that the belt sander didn't quite finish. And I'll go over that entire piece of wood on that side in order to touch up the wood. And then I'll use different grits of sandpaper in order to get a finer finish, which you'll see here in a minute. The final product is something that looks like this, and what you can see very nicely are the alternating dark and light bands. There's the pith, the center of the tree, so the earliest growing part of the tree when it was a young tree. And then each of the rings, you'll notice the alternating light and dark bands that are on there, and each of those is 1 year of growth for this particular tree. And then on occasion, what we will find once we sand a piece of wood is an injury that happened to this tree at some point during its life. In this case, this is a fire scar. So this tree was burned by a fire at one time. Once we have finished sanding, now it's time to measure each of those tree rings. So we have a microscope. This instrument is going to record how wide the tree rings are, and then I record all this on a computer that there is in the background. And so each piece of equipment that I have there has to be, of course, turned on, and there's a special program in that computer that we use that will record each of the rings that I measure. The wood sample is the one that we had finished sanding, and I brought it into this room. And right now what I'm doing is setting up the program and telling it that I'm getting ready to measure a piece of wood. So I'm going to spend roughly 10 minutes on this sample. And I'm going to look through the microscope in order to see the tree rings up close. By seeing the tree rings, I can measure how wide each of those rings are through the microscope, and the computer will record it for me. We always start measuring from the outside ring of the tree and work our way towards the pith, or the center of the tree. The instrument that I have there in my hand is a button I'm going to push every time that I measure a tree ring. I'll push it and it'll beep, and I'll probably do this about 100 times because there's about 100 tree rings on that particular sample. And here in a minute, when we kind of zoom out a little bit, you'll see that I'm turning a little handle on the side of that stage. And what that is doing is moving that piece of wood so that I can measure each wood sample, and then that button that I showed you just a minute ago will record how wide that tree ring was. And so you'll see that I stop and then I start turning that, and each time I'm turning it, it's measuring a different tree ring as I go from the outside of the tree towards the inside, or the pith of that tree. Once we've measured all the tree rings, we then print out a graph. And the graph that you see there is from that sample that I was just measuring. And it's what this graph is showing is a series of wide and narrow rings. That's an example of a narrow ring. It's very, very small. And that's an example of a very wide ring. So that tree was growing very fast at that point. Now, to verify that I have captured and measured all the rings that are on that sample, I have to do something called cross-dating. Cross-dating is a way of verifying that you haven't missed any rings. And so what we use to do this are a series of graphs. You'll see that I'm laying out two sheets of paper. One of those sheets of paper is the sample I just measured, and the other sheet of paper is what we call a master tree ring chronology, the one that's on the bottom there. And what I'm trying to do is match up the patterns of wide and narrow rings, or how the graph is going up and down across that sheet of paper. And by doing so, it tells me whether or not I might have missed a ring or I might have too many rings. And ultimately what this will do is allow me to know when this tree was growing. It might be a certain year, a decade, a century. And so what I need to do is I need to match up the patterns between those two sheets of paper. And so I mark on there the patterns that are matching up. And they should match up all the way across that graph. And so I'm marking where they're matching, and I begin to notice that they're matching up pretty nicely all the way across from one end of the graph to the other. And so I can feel relatively confident that what I'm looking at on the graph is truly when that tree happened to be growing. And so we'll give you kind of a close-up picture of this pattern that I was seeing. And I drew lines on there just so that in the future, if I have to go back and look at this particular graph, I know exactly where it matches up with the graph that is underneath that. And so the light that's shining up through that instrument, I'm able to see both lines. And you'll notice that the pattern there matches up pretty nicely. So all of those patterns are matching up. And I look for that pattern, particularly where the low points are on the graph or on the line, try to match those up. And so this happens to be the finishing point for my research. Once I can match up those patterns, I know that I can feel pretty confident in the years that the tree happened to be growing.